In this video, we're going to take a quick look at some of the ways that these standards could look like in action. We are back on the standards examples document. You are welcome to review these on your own or go through them with me right now on this video. First, we're going to take a look at modeling and simulation. So you'll see that it's broken down into grade band and then the 4 examples for each of the standards. So for example, in kindergarten through first grade, grade band, we have computational thinking, standard 1. So if you don't remember what that was again, you're going to want to take a peek back at your standards document or have them side by side as you go through this. But this one had to do with patterns. And you'll see in the first example here, it says students can study the patterns of snowflakes or butterflies to finish a missing pattern. So this could be something that's done in science, but you're really talking about computational thinking in here. Another example is studying plants and animals in science that can identify real world patterns, for example, butterfly wings, and extend it through their drawings in science. Or students could study origami, and this is definitely something you can do beyond just the kindergarten first grade level. If we move up to 4 through 6, you can see that they can look at the movement of rope to simulate sound waves, or you could use a PhET simulation that can do something similar to that. You could talk about inputs and outputs. You could talk about changing recipes, which could be done in a home and careers course or in your classroom during science or math. And then there's other ones you can do in PE, like tracking your heart rate or how fast it takes you to do something. As you move up into the upper grades, we can talk about collecting our data and developing models and thinking about predictions. So here, for example, this example 4, have students use word predictor on their phones to see how correct it is. This could be something you could do in a Google Doc. You could use voice typing, or you could use the word predictor software to write a story based on what AI is asking you to do or artificial intelligence is asking you to do. So these are just some examples that educators across the state put together for the area of modeling and simulation. But these are not the end all be all. You certainly could choose to do some other things, and you'll see lots of resources shared with you. Moving on to data analysis and visualization. Again, you are welcome to go through these at your own pace. I'm just going through them quickly to kind of highlight a few things, but definitely pause the video or stop the video and go through these in the way that works best for you. In data analysis and visualization, we're talking about creating and reading charts. You can have them take a field trip and see what happens when lunch is bought and how the counts work. You could have the students chart different things. Little ones love when you hand them a clipboard and they get to learn about tallies. You can, in science class or in PE, you can use Fitbits or accelerometers. You can, in the library, talk about how data is collected for the books that are read or things around the bulletin boards. You could have the students do their own polls and so on. Moving on to abstraction and decomposition. Here we can talk about planning different parties. Applied Digital Skills has a whole curriculum on party planning that you can absolutely use. You can create an app using a program like MadLearn, where you can have them solve a real life problem. This could be tied very nicely into a project-based learning activity where they have to solve a problem that they're aware of in their community. Students could absolutely think about how surveys work and talk about how they could find the answers based on different math or different ways to use math. You can have your students draw different shapes and talk about the functions of those shapes and how drawing works with those. You can talk about average sets with scores of whatever it is that you're using, or using lines of code to build math. You can talk about the steps it takes to solve a math problem as we talk about algorithms and programming. You could talk about how you can design different problems to get to the same answer, which is the most efficient way to do it. So you're talking about some really high-end thoughts when you're getting into math, when you're using algorithms. You could talk about ways to sort data, way to merge, sort, and bubble sort. You could talk about how to identify different concepts like current weather. You can explore some jobs that would collect data. I love this one where you could read the lyrics of a song and label the different components like the verse and chorus, and then discuss which components can change and which stay the same. So you have this comparison that you can do. You can also have your students create websites. You could have them create lists. You could have them identify simple tasks. You could have them choreograph a dance that uses an algorithm, or use the dance party one on code.org to do some fun things. Choose your own adventures can work very well here. You could use some different robots, or do different things with different online programs. A sprite is your character that's on, if you're on Scratch, it's that cat, that's a sprite. So you could talk about that with your students. You can do debugging. I taught ELA. I used to have my students debug their essays so that it was more readable. So you can absolutely tie that into your English class. So there's lots of ways that you can tie in these standards into your classroom. And as soon as you start to see those correlations and figure out how to fit it in, this isn't going to feel like a big overhaul for you, hopefully, as you're thinking about how to implement them in your classroom. So take a moment, really dive into the ones that fit with your grade, compare them to what it says in the standard and in the clarifying statement as you explore this concept area.